Hi everyone and welcome to another Geometry Notes tutorial. Today we will be creating the cane that you just saw using Blender Geometry Node. In this video you will learn how to create a mesh to use it as a displacement using Geometry Nodes. I've broken down the video into three main parts. First we'll be building the base mesh, then making a mask for displacement, and lastly applying the material. Alright, let's get started. First, add the base cylinder mesh to the viewport, and then switch to edit mode. Scale the cylinder down by half. Now we will retopologize the cylinder starting from the top. Delete the top face by selecting it, press X and choose faces. Select all the top vertices, press F3 and search for grid fill to revise the n-gon face. Adjust the rotation to align the edges using the pop menu at the corner. Next, extrude top face by pressing E, then right click to keep it in place. While still selected, scale it down by pressing S, then Shift C to lock the scale on the XY axis only. Add another loop cuts for better geometry. Repeat this process with the bottom part. Delete the face, duplicate the top part with Shift D, right click to release, and move it down with G while holding Ctrl key to activate the snap function. Select all vertices, then press M and choose by distance to merge the vertices that's in the same place. Then press A again to select all the vertices and press Shift N to normalize the face. Still in edit mode. Let's double the height by pressing S, C, N2, then enter. Add another loop cuts to the cylinder. And now we're ready for the geometry nodes. In the Geometry Node editor, we will add more faces to the cylinder by converting it to a volume with a mesh to volume node first. Then back to a mesh with volume to mesh node. Set resolution control to size and adjust the voxel size to 0.1. This setup will give us more detailed geometry, and the base mesh is ready now. Now for the masking part. Now let's create a mask to define which part of the cylinder should bulge out. To make things more clear, I will make the main mask on a 2D plane first. Well, you don't need to follow along for this part. Add a plane and switch to the shader editor. I use the default material here and I'm disabling the lighting for clarity. To start creating the mask, I'll use a Voronoi texture and set the feature to distance to edge to create an island-like separation pattern. I'll set all values except for scale to 0, including the randomness, which I'll zero out shortly. Then we need to distort the line using noise and wave texture. If you are using the Node Wranglers add-on, you can have a mix color shortcut by holding Shift and Ctrl, then dragging with the right mouse button of the two nodes, and then change the blending mode to linear light. Similar to the Voronoi texture setup, we can zero out all the values other than the scale. I'll set the scale to 0.3, adjust the blending factor as well, and plug it into the Voronoi texture to get this wavy line pattern. Lastly, we will set the randomness in Voronoi texture to 0 to achieve a cleaner, more defined wavy line. This will be the mesh that we are going to apply on the cylinder geometry later on, where the light areas will represent the extruding parts, while the dark areas remain flat. If you want to adjust the overall scale of the pattern, you can use the mapping and texture coordinate nodes, or simply press Ctrl T with Node Wrangler enabled, then adjust the scale value as needed. You can also adjust the mask gradation using a color ramp to control the extrusion strength. Let's apply this mesh in the geometry nodes. Okay. You can hide or delete the plane. We don't need it anymore. So in the geometry nodes, we will use the set position node as the main node. Then to make the extrusion, we will use the scale node and the normal node. The extrusion or the bulging part will be similar to adding a noise texture like this to the scale, but we will make a different texture like the one that we did on the 2D plane. Again, if you are using the Node Wrangler add-on, you can enabling the viewer node with Ctrl-Shift-left click to preview the node that you are selecting. If you still can't see this Voronoi texture on the object, maybe you need to enable this color opacity setting. Now, as we did in the shader editor, first add noise and wave textures, and then blend them using linear light mode. Set the scale value to 0.3 and reduce the randomness in Voronoi texture to 0. Change the Voronoi feature to distance to edge. Connect the result to the scale node. Use a color ramp to adjust the strength and select B-spline to soften the contrast. There is no mapping node in geometry nodes, but you can use the vector math node set to scale, placing it on the position attribute to replace it. Then adjust the scale value closer to 0 until the pattern emerges. Since the shapes still look pixelated, we can add a subdivision node. And smooth it out with the Set Shade Smooth node. In addition to adjusting the overall scale, you can also rotate the vector using the Rotate Vector node. At this point, I was actually wondering why the shape wasn't the same as in my previous trials. Later I realized it was because the linear light blending value had not been adjusted yet. And that's it, we have our first mask. So for this next part, we will create a mask so that the top, middle and the bottom section not extruded, giving the cylinder an hourglass-like shape. Again, I'll use the viewer node so we can see the mask. Using a position node, we will isolate its single axis by separating the vector with a separate XYZ node. Then selecting only the Z axis. Next, I will add the math node, set it to ping pong, and adjust the scale to 1. We're almost done with this mask. We just need to fine-tune the gradation with a color ramp. If your cylinder height differs from mine, you can adjust the stripe spacing using a vector math node set to scale. Finally, we will combine this mask with the previous one by using a mix color node with the blending mode set to multiply. For finer adjustment, add another math node, set it to multiply and adjust the strength as needed. And we're done with the second mask. Okay, for the next mask, we will make a mask that separate two materials. It is similar with the previous mask, so we can just duplicate it. And instead of using ping pong, we will use another math node. But first we will add a vector node and set it to add. This node will act as a controller for the mask. Now we will use this math node instead and set it to absolute. Now the same as before, we need to blend this mask with the other mask. Use another mix color node and set the blend mode to multiply and plug in the value. And we can start adjusting the value of the mask. You can adjust the values here as much as you like. Basically, the scale node controls the contrast of the black and white border, and the add node adjusts the Z position. Lastly, I flip the color ramp because I want the mask to transition from black to white and back to black. I also add another white color as a holder to make the gradation narrower. And we are done with the third mask. Now let's create a mask for the curve. It is to distinguish the extruded parts. We'll blend it again with the previous mask using a multiply node. Well, mix color and multiply node. We will start with the position node to get the vector position of each vertices. Then we will subtract that vector position with another vector position that has been averaged with its neighboring vector using blur attribute. And the result will represent whether the face is bulging out or not. And to know by how much it's bulging out, we can use the dot product from vector math by using normal and the vector result as its input value. Now the mask is ready and we can adjust its strength using multiply node. And adjust the gradation using color ramp. And now we can drag this result to the multiply node above to blend the mask. And I want to add noise to the mask, so I will mix it with the noise texture. Set the blend mode to mix. Plug this one to the vector. And for the top socket, set the color to white. This way only the part that bulging out will get the noise. And now we're done with the curve mask. Now we can use this value to control the separator and this value to control the noise at the curvature. And you can add another blur attribute here to smoothen the mask. Let's tidy it up a little bit. Select the node setup for the first mask and press Ctrl J to give it a nice frame. Then select the frame and press F2 to give it a name. I call it the squeaky line. Do this to the other set of nodes. The second mask that we created will be called top, middle, bottom. The third mask that will be used to separate materials will be called separator. And the last mask that distinguishes the curve will be called curvature. We need to be able to reference this mask value later on the shader editor. So we need to store it as an attribute. Geometry nodes provide this capability using store name attribute node. We will need to store 3 masks. The first one is the separator. Name it the separator. And plug in the color ramp value from the separator node section. Now that we have stored the value, we can even reference that attribute here in the geometry node. I'll move the separator section up here to keep things organized. And cut the line that connected to the mix color node for now. Now to reference that attribute, use this node called name attribute. Then set the name as separator. And as you can see, it doesn't work right away. Well, I made a mistake here. So we need to place the store name attribute node before the set position node. Now it should be working fine. And for the next mask, we need to place the node here since we need the value after it has been subdivided. Change the name to curvature. Then plug the mix color node from curvature node section to the store name attribute node. Time to instancing spheres. Now we will make another set of geometry node to instancing spheres on every points. Let's make some room for this set of node. Now we need to convert the current mesh to points using a mesh to points node. We can adjust where the points will appear on the geometry. For this setup, we will use faces to make the points or spheres appear on each face. Then to make it appear, we need to add an instance on point node and add an icospheres node, then plug it into the instance socket. Join the geometry using join geometry node to display both the cylinder and the spheres. Resize the icosphere to make it small, around 0.025 meters as its radius. Since we don't need this instance on every point, we can use a random value node to control its appearance and adjust the randomness using the seed value. To smoothen the sphere, we can add subdivisions, but we will save that for later since it's performance intensive. Next, we will make the sphere appear only in the areas with the curvature. We previously stored this value, so we can reference it here. Using a name attribute node, set the name as separator, and plug it into the selection input socket on the instance on point node. We can use a color ramp to adjust the border for finer control. As we adjust the separator controller, it should look like this. To scale each sphere randomly, add a random value node and plug it into the scale socket on the instance on points node. Adjust the minimum and maximum values for the desired variation. Tidy up a little bit here. Add set smooth node to smooth out the icosphere. Tidy up the nodes again. Now for the final mask, which we will reference later, we need to store a random value for each point. Add another store name attribute node, name it points, and plug in a random value node. Set the value to float using the default range from 0 to 1. The random value should look like this. Finally, we've reached the last section of the tutorial, applying the material. We will be using the mesh we created previously, and I will guide you through the base setup, and then you can get creative with however you like. But before we continue to the shader editor, we need to add a set material node at the end of geometry setup, so the material can be applied to the mesh. Let's start by creating the material. Open the shader editor, create a new material and name it candy cane, and then assign this material in the node. Now we can expand the shader editor window to make it full screen for easier viewing. To see the material, enable the rendered viewport. We will be using several principal BSDF shaders. First, let's bring in the mask we created previously. Using attribute node, set the name to separator for the main mask. Duplicate this node with Shift D and rename it curvature for the curve mask. Then add one more code points for the sphere mask. For the points attribute, set the type to instancer. Now that all the masks are ready, we will use them to mix between shaders. Let's start with the separator material. You can replace the shader later if you want, but I'll show you the best setup here. I'll separate each area with different color first for easy viewing, like blue for the areas without curvature and the green for the curved area. For the green area, add another mix shader and use curvature as the vector mask. Plug this like so, then connect the mix result to the lower input on the first mix shader at the top. Now we can have a different color for the extruded areas. To further adjust the gradient, use a color ramp. Finally, let's set up the sphere point mask. This mask contains random values from 0 to 1, so to use it as a vector mask, we will add a math node. Set to greater than with a value of 0. This way, any sphere with a value greater than 0 will appear white. Now you can use this as a vector in the mix shader. Plug the previous mix shader into the top input and add a new shader for the spheres in the bottom input. To add even more variation, use the points mask for a gradient effect so each sphere has a unique color. Use a hue saturation value node for this. It might look overly colorful now, so to tone down the hue variation, adjust the hue range closer to 0.5 using a map range node and set it to float. This creates a smoother gradient. And that's the basic setup for the material. You can follow along or start tweaking it yourself. My version is also available on Gumroad if you like to check it out. That's all, hope you learned something new. Thanks so much for watching, until the next tutorial.